Hey everybody, it's Mr. Bells again. I have a couple things for you today. This is dealing with section 5-2, and there are two examples that we're going to look at. One's called right here, simplifying trig expressions. Again, the first two units in chapter 5 are just kind of getting really good at these Pythagorean ones. Everything that we do in calculus pretty much deals with those manipulations of the basic trig functions. Okay, so here's 9 of them. If you want to pause it and copy any of these down, you can. I don't think I have this sheet up available on the website, so if you want to look at any of these ones, you can. Here, these ones are all simplifications, which means that we're going to try and make them smaller by looking at some stuff. And these ones down here on the bottom, these are all trig identities. So if you want to, again, take a look at this, pause it, maybe copy any of these ones down. All of these trig identities are actually possible. So if it says not possible, they really are on this one. So don't assume that they're not. If it was in class, we'd have more time to be able to work with them and stuff. So what I'm going to do is I'm going to pick out a few of these ones, and hopefully this will help you with some of the stuff from the online homework, just talking about how to manipulate and things we want to look for. Now, reminder again, we had this sheet from before that you should probably have in your notes, and these are the basic fundamental identities, the reciprocal identities, Pythagorean identities, even and odd identities. Those are the ones that you're going to need to have. So hopefully you have that card around someplace for you. Okay, so here we go. Let's try a few of these ones and see what we can think of them. I'm going to let you do the first one because that one's pretty obvious. At least I hope for this one that's pretty obvious. For this next one, what we're going to do ahead is do something like this. And one of the things that we try to do is try and get them all to be the same type of term. So if there's cosines upstairs and there's sines downstairs, we know that we can convert between a sine and a cosine as long as it's squared. So I can take this bottom thing right here, sine squared theta, and I can write it as 1 minus cosine squared theta. And on this top one right here, you can see that I have a cosine here and a cosine there, and you're like, oh, well, what can I do? Can I factor out a cosine? There's cosines on both of them, so yep, so we're going to do a cosine theta times 1 minus cosine theta. And you're like, oh, you're right, but that gives me this. But then I look down here again, I go, wait, that's factorable. That's a difference of squares, right? Try and move that in a little bit closer. So a difference of squares. So that's perfect square and that's perfect square. So that's equal to 1 minus cosine theta times 1 plus cosine theta. Oh, look, I have a 1 minus cosine upstairs and a 1 minus cosine downstairs. So even though it hasn't shrunk down to something completely small, it does break down into cosine theta over 1 plus cosine theta. Now, I've had a lot of students that try and just do this and cross off the two cosines and say, hey, that's 1. Remember, you cannot do that when you have two separate terms in the denominator. If you had two separate terms in the numerator and one thing in the denominator, you could split those so that both of the top two terms are divided by that same denominator. We cannot do that the other way around. Okay, so let's go ahead to this one right here. Sine squared theta plus 2 cosine squared theta over secant squared theta minus tangent squared theta. And I'm like, well, my sheet has a few different things on this. I know that sine squared plus 1 cosine squared equals 1. So let's try and do this. So let's make this sine squared theta plus cosine squared theta plus cosine squared theta, because that's technically what that is. Well, then if I group it right here, then that just becomes 1. So I got 1 plus cosine squared theta in the upstairs. Okay, on the bottom, secant squared theta happens to be the same thing as tangent squared theta plus 1, or 1 plus tangent squared theta. I don't care which way you want to write it. So I can take that and switch it to that with that Pythagorean identity. And I got minus tangent squared theta. And now that kills that because those are opposites, and that's over 1. So looks like I got 1 plus cosine squared theta over 1, or that's as small as it goes. it worked out okay. So I'm going to go ahead and let you try this one right here, cotangent theta and 1 minus cosine squared theta over sine theta. And again, think about what this is equal to. Put that in there. Know that if you have a cotangent, that's really cosine over sine, and the cosine can stay above the fraction, the sine can stay below the fraction, and kind of works out like that. Okay? In fact, I'm going to go all the way here to 6. Hopefully you can look at 4 and 5 and try those on your own. So number 6 looks something like this, and you're like, ooh, that looks kind of scary. But remember, I can break and factor things in parts too. Okay, so I'm going to look at this part right here. And I'm going to say, let's just look at those two terms first. Well, that seems to me that that's a perfect square, and that's a perfect square, and that's subtraction. So I can rewrite this as cosine squared theta plus sine squared theta, right? Times cosine squared theta minus sine squared theta. And then I got this plus sine squared theta at the end. And you're like, oh, wait, I can do that, right? This times this equals what's in my brackets. And then what can I do here? Well, this equals 1, right? So that's just 1. So 1 times anything is just that thing. So then I have cosine squared theta minus sine squared theta plus sine squared theta. Oh, there's a minus 1. There's a positive 1. Look at that. That thing right there is equivalent to cosine squared theta. Sweet. And so you go ahead. You can try number 7 on your own. 7's kind of challenging, but not too bad. Think about this sine to the 4th theta and this tangent squared theta, cosine squared theta. And think about, what could I do with this? Maybe just getting them all over the same terms. Okay, so here we go. I will tell you, at least maybe this would help, that the final answer should be tangent squared theta. Maybe that will be a beneficial thing to you. So number 7's final answer is tangent squared theta. Number 8's final answer is tangent theta. And then let's do this one right here. This one's pretty tricky, I'll be honest with you. You got to do a lot of stuff, but I want you to see some of these things, and hopefully that will help. Okay, so what I'm going to do right now is I'm going to try and do denominator and numerator separately. So I'm going to rewrite 1 plus, this is the numerator, 1 plus cotangent theta as 1 plus, and use its reciprocal identity, 1 plus cosine theta over sine theta. And now my denominator, I'm going to do cotangent theta right here as cosine theta over sine theta times sine theta plus cosine theta, like that. And you can use x's if you don't like writing all these theta things on this. Okay, so the next thing that I'm going to do is I'm going to go ahead on my numerator and try and get common denominators here. And since this was multiplication, if you want to, you can just put a big line over that and just treat that over sine theta. Okay, so this has a sine theta underneath it. This doesn't have anything. If I want common denominators, I'm going to go ahead and rewrite this as sine theta over sine theta, because sine theta divided by sine theta is 1. Sweet. So now I've got this. I've got sine theta plus cosine theta over sine theta, because they're common denominators, divided by, now I got this, cosine theta times parentheses sine theta plus cosine theta over sine theta. And like, whoa, this is one big nasty looking fraction. And then I realized I could copy dot flop, which would then move this sine theta upstairs. Or I could say, hey, they're both being divided by the same thing, so that cancels each other. This has a sine theta plus cosine theta upstairs. That has a sine theta plus cosine theta upstairs. So I'm left with a 1 in the numerator and a cosine theta in the denominator, and 1 over cosine theta equals secant theta. And I'm like, yeah, that's a lot of stuff. What I did, again, one of the rules to simplifying these things is changing everything to sines and cosines, using some algebra skills that we know, common denominators, copy dot plot, factoring, excuse me, those kind of things. So give it a shot when you can. Try those other ones. I'm not going to give you the answers to 4 and 5 because I think you'll be able to get them okay, and I don't want you to just move towards that. So these ones are tangent squared and tangent theta. See if you can do that. Okay, so what's the difference down here? So this says prove the following trig identities. Prove them. If not possible, state not possible. So again, we have already said that these ones are all possible. We're just trying to show that they do work. And one of the rules for proving trig identities was that we're only allowed, right, to work on one side of the equation. Now, it might have been that in your trig classes before you could manipulate both sides, but really aren't supposed to be doing that. So what I try and do is I look at whichever side is the most complicated. So let's work on the first one. This one's pretty basic here. So I got a sine theta. This is supposed to equal cosecant theta. Well, I know what cosecant is 1 over sine. So if I can just get a sine downstairs out of this, then this will work out. So most of you will go, oh, well, I can do this, sine theta. And I know that 1 minus cosine theta is sine squared theta. You're like, hey, I can do that because that's a Pythagorean identity. And then I can simply reduce this and I get 1 over sine theta, and that's just doing division or quotient rule. And then 1 over sine theta is cosecant theta, and that's what I wanted it to equal because that's my right side of my equation. Again, it doesn't matter if you manipulate left or right, as long as you just do one of them. Check mark, hey, I've done that. Some of the online stuff is going to ask you to justify again what allowed you to go from one step to the other step. So again, 1 minus cosine squared theta equaling sine squared theta is a Pythagorean identity. Sine theta divided by sine squared theta is just simply doing a quotient or division rule. 1 over sine theta is a reciprocal function with cosecant theta, and that's what I wanted it to equal. Okay. So I'll go ahead and do the second one too, because that one sometimes is challenging for some people. And what I'm going to look at is this. I'm going to go, hey, these first two terms have a cosine in them. So I want to try and pull a cosine out of those first two terms and see what I get. So cosine, and just, again, that's what I'm talking about, these first two terms. Because definitely the left side is more complicated than the right. So I'm going to manipulate the left. So cosine squared theta, I'm going to pull out of this. And I'm going to be left with cosine squared theta plus sine squared theta, right? Plus sine squared theta. And we're going to hope that it equals 1 when we're done. And then I look in the parentheses and I'm like, hey, that's a Pythagorean identity. That's just 1. So then I get cosine squared theta times 1 plus sine squared theta. It's supposed to equal 1 again. And then anything times 1 is itself, so then I can write cosine squared theta plus sine squared theta equals 1, and that equals check mark, smiley face, all said and done and good. Okay, so I'm going to let you try 3 and 4 on your own. Again, they do work. So this one you should try and prove that it equals cotangent theta right here. This one right here, you should try and prove that this whole right side over here equals 1. I think you can do that okay. So this one's a little sketchier, so I'm going to go ahead and try this with you guys and see if this makes sense for you. Okay? In fact, because of the fact that it requires a little bit of stuff, I'm going to go ahead and move it on to the back. Okay? So here we go. So I'm going to try this one. So 1 minus cotangent to the 4th theta equals 2 cosecant theta minus cosecant cubed theta. There we go, looking just like that, right? Let me move my camera here a little bit for you. And that's all divided by sine theta. Okay, so you might think that this one's scarier because it's got a degree 4 on it. You might think that this one's scarier because it's got 3 different terms on it. I'm going to see if we can just kind of, I'm going to manipulate the right. And really, that doesn't matter if you do the left or the right, you just can't do them both. So here we go. Let's try the right-hand side. I'm going to take this sine theta and I'm going to shove it upstairs. And remember, we said this before, if I only have one denominator and I have 2 terms in the upstairs, I have to shove it into both of them. And you know, if you move sine upstairs, it becomes cosecant. So that would give me 2 cosecant squared theta minus cosecant to the 4th theta. I'm like, ooh, that seems kind of big, yeah? But wait, they both have the same thing in them, so let's see if we can pull that out. So I'm going to pull out a cosecant squared theta. So I pulled that one out, and I'm left with 2 minus cosecant squared theta. I'm like, oh, that's okay. And but I'm supposed to get something that looks like cotangent to the 4th. And in my head, I'm looking at this and I'm going, well, that's a difference of squares. So that's 1 plus or minus cotangent squared, right? 1 plus cotangent squared and 1 minus cotangent squared. Well, look at that. Cosecant squared happens to equal, according to my little chart over here, 1 plus cotangent squared theta. So now I got half of that thing. And over here, let's try and do this. So I'm just going to rewrite this again, this right here. As 2 minus, and then cosecant squared theta is 1 plus cotangent squared theta. So distribute the negative in, and 2 minus 1 is 1, right? 2 minus 1 is 1, and then minus cotangent squared theta. So that's 1 minus cotangent squared theta. Well, look, and this is a difference of squares. 1 times 1 is 1. Minus cotangent squared on the outside plus cotangent squared on the inside. Those cancel each other, and cotangent squared times negative cotangent squared is 1 minus cotangent to the 4th theta equals 1 minus cotangent to the 4th theta. Check mark. Now, I'm going to be honest with you guys. I've been doing this for 20 years. There's lots of them that I can just look at and kind of go and process and kind of know what to go. But there's a lot of other times where I just do stuff and sometimes it looks rough. And that's okay. That's okay. Sometimes I'll do one of these same proofs and be like, I can't do anything with this. I don't know what to do. That's okay. It's kind of like a maze. So we're going here, we're going here, we're going here, we're going around the maze, going around the maze, and all of a sudden I hit a wall. And I can't do that maze anymore. So then I tried a different way. And maybe there was a branch off over here, and I come back into this way, and I hit a wall again. And at this point in time, I feel like going, let's just erase part of that wall, right? But then I realized there was another break right over here, and I can come into this area, and yay, there's a little opening over here, and I can be successful. And I can leave. So one of the main rules in mathematics that we're trying to push, you remember it above my desk, is the word perseverance. And that's what you got to do with some of these things. You have to persevere. You have to keep trying stuff. You have to keep looking at your things and go, hey, let's try something. See if this works there for me. In the next video, I'm going to do something that'll help you with that too. So hopefully that was helpful that we just did that one check mark. So let me do one more of these things and see if this is beneficial. Let's go ahead and try, let's try number 7. Number 7 looks kind of scary. And you're looking at this going, hey, I got this right here, which is cotangent squared theta cosine squared theta equals cotangent squared theta minus cosine squared theta. And part of me would just go, well, that probably just doesn't work. That just doesn't make sense. That 2 things multiplied together are equal to the same 2 things subtracted. from each other. But like I said, it is true. The question is, how do I get it to become true? Okay, so here we go. Then you have to ask yourself, which side is more complicated? Is it the multiplication side or is it the subtraction side? It's always a little bit more complicated if there's two terms. So that's what we're going to try and do right now here is this. We're going to try and get these two terms to become one. So I'm going to rewrite cotangent squared as cosine squared theta over sine squared theta minus, and again, I need them to have common denominators, so I'm going to add an extra sine squared to both of these. Cosine squared theta sine squared theta over sine squared theta, like that. I just simply multiply top and bottom of this last term by sine squared theta, and now they have the same denominators. So now I have cosine squared theta minus cosine squared theta sine squared theta all over a single sine squared theta, because again they have common denominators. And I'm like, okay, what can I do with this now? It looks like in my numerator, right? Don't I have cosine squareds twice? I feel like I do have those both times. I can also change this cosine squared right here, or this cosine squared right there, to 1 minus sine squared theta. Look at that. Let's try that. So I factor out a cosine squared theta. I'm going to come right up here. So this is my denominator. Factor out a cosine squared theta, and then I'm left with 1 minus sine squared theta. Do we see that? Pulling the cosine out of both of those. Well, cosine squared theta, let me write the bottom again. This is over sine squared theta. Well, 1 minus sine squared theta is cosine squared theta, right? And look at this. So I'm going to do two things at once. So cosine over sine squared theta is cotangent squared theta, and 1 minus sine squared theta is cosine squared. Wait, is that right? That's what I wanted it to equal, and that is what I got. Okay, so you can go ahead and try on number 8 if you want, see what it looks like. And the final thing I'm going to leave you with is this. I'm going to go ahead and do it on the sheet right here. Is one of the things that I did to help get myself better at some of these things was just to try some stuff. And we would have done this in class several times, and maybe we have practiced this depending on what year you're watching this video. Is I might write something like this. I might go, okay, let's go ahead with, I'm going to start my thing as cosine squared theta. Good deal. Well, we know that cosine squared theta is equivalent to 1 minus sine squared theta. Is that correct? I know that that's true. And I know that 1 minus sine squared theta is equal to 1 minus sine theta times 1 plus sine theta. That's true. And then I could rewrite this as 1 minus 1 over, and if I move sine theta downstairs, tell me everybody now, what is it going to equal? Sine theta downstairs, awesome. Cosecant theta. And let's do it for the other one too. Go ahead and move that one down. 1 plus 1 over cosecant theta. And I know I've just done a few different things here, but guess what? If I started with this, and I manipulated it, and manipulated it, and manipulated it, it's still equal to what I started with, cosine squared theta. And look at that. That is a wonderful identity for somebody else to try and practice on. So you can do that with anything. You just start with something, and you manipulate it, manipulate it, manipulate it. I try and do only 3 trials of this, because I don't want them to get too messed up. I've had people go nuts in the class before on some of these. So again, big picture, all of this stuff that we did today was on trying to simplify trig expressions and then prove trig identities. Hoping this was beneficial, hoping this will get you through some of the stuff that's in there. Remember that you can also watch the videos that go with the stuff, or the help me solve this, or honestly, I'm home a lot. I've been trying to do some things to help you guys out, but send me an email if you need to, if you want to do this. Keep up the good work. Keep supporting each other. Again, if you guys are watching this in future years, this is from the at least the spring of 2020, where we had a little coronavirus going on in the United States, and it's kind of changing the way we do stuff. So take care of yourself, and spend a little time with your family, and support each other. This is Mr. Bells. You guys have a great rest of your day. And hi again to all those moms and dads out there listening in the background.